Lesson 57, rational equations, basically day one here. Rational equations, obviously if it's an equation it contains an equal sign, and a rational equation would contain one or more rational expressions. Extraneous solution. Extraneous solution is just a fancy thing for excluded value, which we talked about before. So if it says check for an extraneous solution, you're checking for the excluded value. Basically what that is that the denominator can't be 0. So you're figuring out what can not be used for that variable to make this denominator 0, because we cannot divide by 0. A little note here. Note is basically saying that if you have rational equations that are in proportion, you can go ahead and use your cross multiplication. So cross multiply and divide. First example is an example where we have it in proportion. So we're going to go ahead and cross multiply here. You have 4 times that binomial there. So we'd have something that looks similar to this. That would be equal to, well, you'd have 7 times the binomial over there, x minus 3. Go ahead and do your computation here. Distribute, we have 4x, negative 4, 7x, and negative 21. And you have to go ahead and get x by itself here. So I'm going to go ahead and subtract 7x, and I would have negative 3x, drop down negative 4, drop down negative 21. Get x by itself. Add 4 to both sides. We have negative 3x equals negative 21 fourths. And then we need to get x by itself. So here we would go ahead and divide by, we'd have negative 17 here. And we go ahead and divide by negative 3 on both sides. And we have x equals to 17 thirds. So this would be our answer here in example 1. Example 2, same thing. We're in proportion here, so we can go ahead and cross multiply. We have r minus 8 multiplied by 2 equals r times 10. Well, if you have r times 10, we would get basically 10r. Distribute your 2. We have 2r, and we have 2 times negative 8, which is negative 16. Get our r's on one side, so I'll subtract by 2r. And I have negative 16 equals 8r. Get r by itself. And we have r equals negative 2. So this would be our solution there for example 2. Example 3 will pose a little bit more of a challenge just because we're not in proportion here. We have an addition piece happening onto that side, so we have some steps that we need to take here to solve this equation. In order to solve the equation, the steps that we have is step 1 is find the least common denominator that we can have on example 3 here. Step 2, multiply the entire equation by the LCD. So make sure you do it to both sides. Cancel out the denominators, so simplify. And then step 4 would be solve the equation that remains in the numerators, and then check for extraneous solutions. So step 1, we need to find our least common denominator. Couple things you could do when we talked about least common denominator. You could use that L method. L method works pretty well if you have some monomials. Otherwise, you can list out the common factors. Prime factorization to figure out your least common denominator. I did my prime factorization. I figured out that 2 is used once, 3 is used once, and the most times n is used was twice, so I'd have n squared. So basically, I would have 6n squared would be my least common denominator. That would be your step 1. Step 2 is talk about multiplying both sides of your equation by your least common denominator that you found in step 1. So I'm going to multiply by 6n squared, multiply by 6n squared. I'm just going to go ahead and rewrite the problem. So when I distribute 6n squared, I would get 6n squared over 3n plus 6n squared over 2n squared equals, when I multiply here, I have 18n squared over 2n squared. Now in step 3, I could basically take each each piece of the fraction here, or each of those terms there that I have, and cancel out the denominators. So if I take the first one, I have a 6 and a 3. Well, a 3 can go into both of it twice once. I can factor out an n, and I'll be left with an n on the top. On the bottom, or next term, I can factor out a 2. When I factor out a 2, this is a 1, this is now a 3. I can factor out an n squared out of each of those. Next, on the last one there, I can factor out a 2. This will become a 9. I can factor out an n squared, and I can factor out an n squared. So basically what I'm going to go ahead and do is rewrite this problem to show you what remains. In that first set here, I basically have 2n on the top plus, well, my denominator is going to be 1. What you did in that step is basically got rid of your denominator. Next term, I basically have a 3 left, and the last I have a 9 left. Now you're to solving equations again. So get your n alone, subtract 3 on both sides. I have 2n equals 6, and then I need to get n by itself. So divide by 2, divide by 2, we find out n equals 3. So that solving equation piece basically here is step 4. Your last step is to go ahead and check for extraneous solutions. So basically, we found that n equals 3. Well, if I put n into that original problem up here, in for 3n up here, 2n squared, or 2n squared, I wouldn't come up with it with 0. So 3 is not an excluded value or an extraneous solution. So there is no extraneous solution. So your answer here in 3 is n equals 3. Example 4 will apply the same technique as we did in example 3. So first step, why don't you go ahead and find out your least common denominator. Pause the video, check back in, we'll see how we did. I just went out and prime factorization and everything there. So 2 would be used, a 3 would be used, and then n has a power of 3 there, so that would be used, and we have 6n cubed is basically that least common denominator. So step 2, remember, is to go ahead and multiply everything by your least common denominator. So I'll multiply the left side by 6n cubed, then I'll multiply the right side by 6n cubed. So next thing, you'd go ahead and distribute that into all of your terms there, and we have 6n cubed over 6n minus 6n cubed over n cubed equals, distribute here. When we distribute into that, we have 6n to the 4th, and we have minus 6n cubed all over n cubed. And really, if you think about it, that last step, you really wouldn't need to distribute that. Reason why is if you left it as not distributing, you have the 6n cubed, what you had to distribute, and you leave it as n minus 1. Well, this is what I'm just showing you. So if you don't do that, it'll make it easier for you to simplify things. So basically, in that first term, we can go ahead and we could get rid of a 6 out of each of them. Well, we get rid of an n off the bottom, so we need to get rid of n off the top. So we're left with n squared basically on the top. Next term, you have 6n cubed over n cubed. Well, your n cubes would cancel out, so you're left with minus 6 equals. You look at the next set here, and you can take out an n cubed right away because it's factored out already, versus if you distribute it in, it would still be there and you'd have to factor things out. So we'd be left with 6 parentheses n minus 1. So I'll continue on with this problem here. I'm going to go ahead and distribute. We have n squared minus 6 equals, distribute 6n minus 6. I'm going to go ahead and get my like terms kind of on the same side here, everything on the same side. So I'm going to subtract by 6n, and I'm going to go ahead subtract by 6n. I'm left with n squared minus 6n minus 6 equals negative 6. Add 6 to both sides. And we have n squared minus 6n equals 0. The next part is kind of bringing back a little quadratics and kind of similar to the zero product property. I'm going to go ahead and factor out an n out of this, so I'm left with n minus 6 equals 0. So everything is equal to 0 right now. So what I'm going to do is I'm going to take those terms and basically come up and set them equal to 0. So I'm going to say this term n equals 0. My next term would be n minus 6. Set it equal to 0. So really what I'm coming up with is says n is equal to 0, and this last one is, well, I'm going to add 6 to both sides, and I have n equals 6. So it looks like right now I have two possible solutions, n equals 0 and n equals 6. Last step is to check for your extraneous solution. So I need to use 0 and 6, and I go back to that original problem up here. If you look at the denominators here, 6n, n cubed, n cubed. Well, if I substitute 6 in for n here, I'm okay. Substitute 6 in there or 6 in here, all of those would be fine. The denominator would not be 0. However, if I put in 0 for n, because remember we came up with two answers. If I put in 0, 6 times 0 is going to give me 0. I have a denominator of 0. You cannot have a denominator of 0. So basically, our answer here is n equals 6 solved, and the extraneous solution is 0. So this will conclude our lesson on 9-5 Rational Equations, Lessons 57.